Good morning and welcome back to Darasacom. I hope you've been learning, and yesterday we started looking at chemical families, subtopic alkali metals, and we learned a lot. And as I always say, make sure that you have a pen and somewhere to write so that we can learn together. Karibu sana Darasacom. So yesterday we left off with a question that you were supposed to answer, and let us look at the correct answers. The first question was, are the above elements metals or non-metals? And the correct answer was metals. How do you know whether it's a metal or non-metal? You look at the atomic radius and you compare the ionic radius. Whenever the atomic radius is larger than ionic radius, then that is a metal. Compare the atomic radius and ionic radius of element Y. The first statement is that the atomic radius is larger than ionic radius. Make sure that whenever you answer in such a question of comparison, you use comparative terms, that is larger than, smaller than, weaker than, stronger than, and then you can explain by saying that Y forms ions by losing electrons. This increases the effective nuclear charge on the outermost energy level of the ion, bringing it closer to the nucleus, resulting to reduction in size. When explaining, make sure that you use the correct terms. Thank you, and let us continue. So yesterday we introduced the alkali metals, and you say that these are metals of group 1 of the periodic table, and you say they include lithium, sodium, and potassium. We say that the atomic radius increased down the group due to increase in number of energy levels, and we also say that atoms of alkali metals are larger than their corresponding ions. Today, let us continue and look at trend in physical properties of the alkali metals, and you are supposed, or we will watch a video, and then from the video you should be able to give the following properties and their trends, that is appearance, ease of cutting, melting, and boiling points. So make sure that you pay attention so that you can note those particular points.
Now in this video we shall look at physical properties of alkali metals. As you can see, alkali metals are generally soft to cut. This is lithium, and when freshly cut it has a shiny metallic luster. But interestingly, you'll observe that after some time the shiny metallic luster tarnishes. At the end of this video you can try and explain why the metallic luster tarnishes after some time, and you can see it has completely turned black. And this is sodium. Sodium is kept under paraffin. At the end of the video you can discuss why it is kept under paraffin. When freshly cut again, sodium has a shiny metallic luster, but you observe that it tarnishes faster than that of lithium. This is potassium, again very the softest. As you can see, it tarnishes very fast. It's almost not possible to see the shiny metallic luster. So can you discuss why the shiny metallic luster tarnishes?
From the video, we were able to see that in terms of appearance, alkali metals have a shiny metallic luster when freshly cut. However, the surface quickly tarnishes due to reaction with air. The rate of tarnishing increases down the group as the rate of reactivity of the metals increase down the group. Then ease of cutting. Alkali metals are soft and easy to cut. The softness and ease to cut increase down the group, and the reason is because due to decrease in the strength of the forces holding the atoms together as the size of the atom increase down the group. So as the atom becomes bigger and bigger, the strength that is holding the forces that are holding the atoms together become weaker and weaker. The melting and boiling point. Alkali metals have relatively low melting and boiling points. The melting and boiling points decrease down the group due to weakening of forces holding the atoms together as the size of the atoms increase down the group. Conductivity. Alkali metals are good conductors of heat and electricity due to the presence of delocalized electrons. Delocalized electrons are those electrons that are in the last energy level. They're able to move from one position to another, as you will see in the video that we are about to see next.
As you can see, within the metallic structure, the electrons in the last energy level of each atom can change position, and that is why we say that they are delocalized. That is, they can change position. It is that movement that enables them to conduct electricity and even conduct heat.